piecewise function. This is where things get really interesting. Because if you remember, one of the things that happens with a piecewise function is that I can have a jump discontinuity. Well, we haven't talked about continuity yet. But we can have a jump in the graph. We can have a jump in the graph. And if I were really going to look at, and this can be a big mistake on my part, 1 divided by x minus 1. That's what happens when I don't plan stuff, always. And x squared plus 2x there they are, and I'm going to put a zoom standard on this thing to see what's happening. And because this is a piecewise function, and let's see, it tries to put in 1. Oh, I know what it did. It's still, I think, going to have a problem, because if I try to graph it, let's see, oh, we should be fine now. Now from, at 1 is where the parabola starts. So normally, I didn't want to write on my calculator. X is going to be what? Less than negative 1? Well, negative 1 doesn't cause a problem. Okay, that should give me the piece that I want. Yep. And then multiply this. Been a while since I've done piecewise functions. Times. And x is going to be greater than negative 1. Now I'm using a logical statement here. Ooh, didn't like that. Oh, there it is. And you notice, what is that negative 1? A broken, right? It's broken. So there is a jump. That means if I come in from the left, I'm going to get one limit. If I come in from the right, I'm going to get an other. Come in from left, I'm going to get 1. Come in from the right, I'm going to get another. If I do a zoom decimal, we'll get a better look at it. There's a jump there. Now, what the logical function that I did is this. It's a test. Whenever x is less than negative 1, it'll plot the value. In other words, it's 1. Whenever x is greater than negative 1, it would be a 0. So when I say x less than negative 1, then it'll give me the value, and it'll give me 0, which is why you see it go along the x-axis. Right? So it only gives me that piece of the graph. So I ignore the stuff that's on the x-axis. That's what that guy would look like if I were to graph him. And I can see it looks like 1, it looks like it'd be about negative 1/2. The other one looks to be about -1. So if I come in from the left, maybe about -1/2. If I came in from the right, it looks like -1. So this says I want to take the limit as x goes to -1 from the left. Now if I'm to the left of -1, that means I'm using the top function. Because that's for everything to the left of -1. So this is going to be essentially 1 over. -1 doesn't cause a problem, so I can just plug it in. And of course, this then becomes -1/2. And then if I'm looking at the limit as x approaches -1 from the right, now if I'm to the right of -1, it's going to be the second function, x squared plus 2x. Because I'm interested in x values that are bigger than -1. Well, again, -1 doesn't cause a problem, so this is -1 squared plus 2 times -1, which is 1 minus 2, or -1. But that's what the graph looks like. If I take a look at the graph itself, oops, I guess I have to turn it on. I'm going to have to take a look at the graph, turn it on. If I come in from the left, it looks like it stops at 1/2. If I come in from the right, it's going to stop. Looks like it stops at -1. So that makes perfect sense.
Does that mean -1? As x approaches -1 from the left? Under that.
From the right.
Oh, from the right. Yeah. Oh, sorry, that looked like you need to sign.
Oh, I'm sorry.
No, I'm
Yeah.
reading that wrong.
Big old -1. See, if it's not going to cause you a problem if you plug the number in, you just plug it in. And what you get is what you get. If it causes you a problem, that's when you're going to have to pick like the 1.99999.